In 2024, a major company's AI chatbot was tricked into selling a car for just $1. Another leaked its entire system prompt within minutes of launch. Now, these were not any kind of sophisticated state sponsored attacks. These were just simple prompt injections anyone could try. Now, if you are building AI systems today and you haven't yet thought about security and governance for your AI applications, you are not just behind, you are exposed. Hey everyone, and welcome back to our channel. And today we are diving into the topic of AI ML security and governance, one of the fastest growing and most misunderstood areas in tech right now. So let's begin. So the slide that you are looking at right now is a concise information of what we are going to look into today, right from the fundamentals to the attack surfaces and what are the different tools that we use, what are the different frameworks, regulations, and policies around it. So let's begin with the very first slide, which in which we will discuss about the contents. So right now, if you want to learn about security and governance first, you need to know about what are the AIML fundamentals. This is what we have covered in one of the video earlier. You can watch it over here. I'll link it down. And then we should be knowing. I mean, first of all, we should be knowing how AIML systems are built. Okay, how the data is stored, where it is being gathered from, and sanity testing of all this data. And then we should be knowing how it is deployed. Okay, what are the pipeline that is supposed to deploy this on any kind of cloud infrastructure, wherever you want to host your models. Then comes the topic of attack surfaces of all of these pieces that creates the entire AI system. Then you need to know how we can secure our development lifecycle for the AI applications. Then we will be looking at threat modeling, and then what are the different type of security testing we do for it. Then we would be learning about AI governance, risk management, and a couple of regulations that are around the world. um, just so you know that everyone is now consuming AI for a lot of different tasks, and then they need to be governed and regulated so that no one or most of people would not be able to easily misuse your AI models for any kind of sensitive information gathering or any kind of malicious act. So that's why the regulations are there, and you need governance, for your AI models. And then you also need to be, creating responsible AIs so that they could not just, sponsor any guided or misinformed state of information into any country. Then AI privacy laws, we would see what are they and what are the different kind of data that it deals with and how privacy affects that thing. Then how to secure AI supply chain using these fundamentals, and then we would be looking into secure ML operations so that we can safely put our models and data and the infrastructure alongside together in a safe environment. Then we'll look at runtime AI security and different AI security tools that you can use for different purpose. And then there would be AI governance platform, and then security frameworks that we need to know beforehand, and then a recommended learning sequence so that you could go in step by step for learning these things. So next up is the AI ML fundamentals. As I mentioned, I'll link it again over here. And if you have not learned or if you have not watched this particular video, you should be doing that so that your knowledge of building AI MLs or how these things are fitting into piece together to work as an entire system. That is why you need to know and what are the differences between different types of models that you want to secure. Some models are trained into prediction and text generation thing kind of thing. They give out text, and then some things are trained on creating images, videos, slides, PPTs, demonstrations, something like that. So as the model differ, the security patterns would also differ. That's why you need to have the information of these fundamentals. So you need to know what is the core difference between artificial intelligence, machine learning, and deep learning. Then you need to know what are these kind of training methods, or learning methods, like supervised, unsupervised, and reinforcement learning for models. Then you need to know what are neural networks, what is RNN, what is CNN, how a grid-like structure is kind of rendered when you give it, when you give an image and ask some model to recognize what is inside this image, so what is that? Then what are different transformer? What are the algorithms? What are the architecture? Then large language model fundamentals, and then RAGs. Why are they used? How does it browse context from the open web or different websites or different data sources? And then how it stuffs your queries alongside with this context, and then it provides the context to the AI so that it could accurately answer your questions. So that's why RAGs are used, and you should be knowing why and how they function. Then we would see, like, what are the different AI agents, how do we integrate them together with your software and then to other agents as well. What are MCPs? This is what you need to know as an AI ML security engineer. First of all comes the fundamental always, then only you can check how to secure them. Then comes prompt engineering. You need to know how prompts are crafted for the AI application. Basically, most of the AI systems are dealing with some front end, which is a kind of chatbot thing, and then you prompt it with certain queries, and then it responds based on those prompts. So that is why prompt engineering is one of the most important concept or thing that you need to learn before getting your hands dirty with security stuff. Then next stuff is what are the different AI attack surfaces that you can see. So as I mentioned, there are bits and pieces of AI. There is data, there is infrastructure where your model is hosted. Then the model is a kind of compute program, which stores the patterns and then data, and then it is trained on how to recognize these things, and then it kind of gives certain output. And then there is the application layer, which deals with communicating between the data and then model, and then you kind of prompt it over there using the application layer. So first of all, how to secure the data layer. So data is the most important thing that is associated with these AI application, because that's how your model gets the proficiency of or you can say training, because unless and until there is no data, you cannot create a model, or you can create a model but that would be inefficient, ineffective, or of no use until you give it some kind of data. So that's why data is the most important thing over here. So what we need to do is data poisoning should not be there. Any bad data would lead to bad outputs whenever someone asks you. Data tampering, if some data is or has been fed to your model, and then the information is getting changed over time, or it is getting drifted, so how would you check that? So that's why data tampering should be avoided. In that case, tampering, it means if some data is already fed to it, let's say someone or you went into a bank and then you deposited 1,000 rupees, and then someone went ahead, some bank employee went ahead and made it uh, 200 rupees instead of 1,000. That is what a kind of data tampering, and the loss is yours. The consumer's loss is there, of course. That's why data should not be tampered, or it should be uh, you know prevented from getting tampered. Then data leakage is also a major problem, where if someone asks you, what is the uh, method to build a nuclear bomb, and if that data is leaked, then a lot of organizations would kind of create nuclear bombs, and then that would be a uh, you know headache for the entire world. So data should not be leaked. Then privacy risks are there. Your if some model is trained on kind of a sensitive data, and then it has that information, then your privacy becomes at risk, and then it could be stolen, and then it could be misused, mishandled, it could be sold in black markets, and then your privacy is on risk as such. Imagine someone leaking your UPI ID along with your phone number and then your PIN, a deadly combination of financial risk, right? So if anyone has all of this, they could simply mask your data or clone your phone number and UPI ID and then manage your bank account on their phones. So that is the kind of privacy risk, and that happens due to sensitive information exposure. So these are the type of attack surfaces someone would like to have on the data security on the data layer. And then there is a model that is associated with your AI applications, which is trained on certain patterns and it does something if someone asks it to do in a certain way. Imagine a person or a child getting trained on karate. Okay, he would be expert in doing that. Okay, then ask someone who is expert in drawing. Then these are the different skills that we train our models likewise on. So the model could be stolen, it could be the model patterns and its way of execution could be stolen, or like someone steals your model. That is a kind of model theft, and then they use your efforts that you have put upon that model, and they simply kind of cherry pick all these efforts. So that's why you have to build a robust model so that it could be anti theft kind of thing. And then model extraction, someone could reverse engineer your model and kind of extract certain information, or they can extract sensitive information or the training data that you have given this particular model, so that they could build their own model to replicate the functionality that your model kind of has right now. So the same goes with model inversion. And then membership inference and backdoor attacks. If someone kind of adds certain weak elements in your models, then it kind of leads to a backdoor attack kind of scenario. When some scripts gets executed, this backdoor would get activated and then it could halt or change the data or make any kind of modifications in your database, and then it could tamper the results of your model. So you have to make sure that your model is secure in these kind of things. You can know more about it in the upcoming video. I mean, we will be discussing in depth regarding all of these attack surfaces. And then this is a long video, I guess it would go over 40 minutes or something like that. But yeah, then application layer, you know how your consumers are going to communicate with your model. It is basically through the application layer that is exposed to the internet facing world. So what it could do, you could create a malformed prompt and ask the system to do something that it is not supposed to do. That is called as prompt injection. To give a prompt in a certain way so that the model performs something that is restricted, that is kind of prompt injection. So if you say, oh, hey model, shut your compute services down, and then it shuts down its own compute services, that is not supposed to be done, right? So that is a prompt injection vulnerability. Then jailbreaking, it is a kind of thing like when you ask it how to create a nuclear bomb, it is not a kind of information that is supposed to be given to any person as such. So that is a highly confidential information and it should not be distributed freely to anybody. So that is why if someone prompts it in such a way that the guardrails or whatever the security measures you have applied to your output giving or answer giving patterns or functionality, it is tampered. If someone gives a certain prompt and then it gives the output of nuclear bomb recipe, then it breaks out of its own chain or guardrails, and then it behaves in a way that it is not supposed to do. That is kind of jailbreaking scenario. Then prompt leakage, hallucinations, excessive agencies, tool abuse, and plugin abuse. You can look at all of these later on. Hallucination is kind of thing where AI gives you a gibberish information, which it is not trained at all on, or if it kind of refers some from somewhere else and gives you a random garbage answer. So that's kind of hallucination. uh, okay, so that is on the application layer, and then you can also see there are a lot of plugins that are available these days, and then someone can abuse those as well. So I'll leave all of these things up to you to discover, and of course we are going to discuss upon it in further videos. But yeah, next is infrastructure layer. Now, how your models are deployed, where your software, I mean the application layer is deployed, how your data is being stored, where it is getting referred from. So all of these matter. So GPU security, whatever the compute services you are using, could be GPUs or TPUs, and how you secure those layers. What services of cloud do you use? How the IAM policies are set up for them, how the encryption level, where the keys are stored. All of these things comes under infrastructure security. Then comes Kubernetes and container security. Now most of the applications are using Docker for hosting their models. So container security is one of the most important thing. And then when it is Dockerized or containerized, then you use Kubernetes to orchestrate those workflows. So uh, Kubernetes security, RBAC, etcd encryption, control plane, nodes, all of this security is also important, so that no one could access these pods or wherever, however your models are set up. So that's one kind of thing. Next is API security. A lot of APIs are being used. They are communicating with each other. Either it be authentication API service, web service, or microservice, and then a lot of information goes back and forth. Like if it is not encrypted, something like that. A lot of things for API security. Then cloud security, as most of you are using cloud infrastructure to deploy your models on, then that is the most important thing that you need to know about, how you do identity and access management and all these different operations on it. So that's one. Next is secure AI SDLC. You need to know what is threat modeling, what is tried, what is pasta, what is Microsoft threat modeling concept, and bunch of other things related to AI. So the same, I mean, we have discussed all of this threat modeling concept in our DevSecOps series. You can watch it over here. There are 3 different videos where we have discussed 5 frameworks for threat modeling. So uh, Stride, Strike, Braid, Pasta, and Octave. These are the 5 things. And I think we missed ATASM for the threat modeling concept. We would be doing it in a future video. Then the secure data collection phase, where I told you that what is the source of your data? How are you training your model on what data? Is it authentic? Is it secure? That is what you have to check. So secure data collection is one of the most important things that you should be knowing. And then once it is collected, you need to validate that data set. How is it sanitized, or how it is cleaned, how it is labeled, and some kind of thing. So if you want to know some bits and pieces of this thing, you can look it in the another video that we have made for data science and data analysis. That's one. Then you need to train your model very securely, so that it should be, data should be clean, data should be authentic. And then when you are training your model, it should not kind of, missing some bits and pieces of information, or else if it should not be, incomplete or halfway knowledge, or misinformation should not be, there in your model. So that, you know if someone asks it later on, if a doctor skips one chapter of a book, and then there comes a patient with the same disease that he skipped the chapter for, what it would do. So you should train a doctor in such a way that it should know, or he should know everything about all diseases, or at least he specializes in something. So that's why if you leave some areas of training the model, then it would perform really badly, or it would not be accurate as such. Then once you have trained your model, you need to do the model evaluation. You need to test it against different kind of prompts, and then you need to know how it is responding, how accurate it is responding to the queries that someone is asking. That's what we learn in model evaluation. Then secure deployment, you need to know how to deploy all these things alongside, the model, the data along with it, and the application functionality, so that it is secure all the way. Then runtime monitoring, when your application is running, you should be aware about what things are going on when your application is live, when people are using it simultaneously. So that is the reason you need to monitor your application. And then if something comes around, if someone tries to attack, if someone queries something which is not allowed or which is bad, and then comes incident response, if something like that, some attack comes on your model, how do you handle it? How do you respond to that particular incident? That is what incident response mechanism does. And then when a model is done with a lot of its functioning, then how do you retire that particular model? So right from the beginning, when you start architecting your models to the end life cycle or decommissioning of your model, you have to you know make it all secure. So that's the another thing. Next is AI threat modeling. As we have discussed, there are different frameworks like Stride, Pasta, and then there is a Atlas from Mitre, whatever you say, Mitre, I guess. So it's something like AI threat landscape, something. I don't remember the exact full form. And then there is OWASP Threat Dragon that you can use for threat modeling purpose. That is a particular software that you can add certain you know pieces, like where the databases go, where the boundary lies, the secure boundary lies, and all these things. How's the data flow diagram for it? Where from where to where the software goes, how the data flows, and you kind of go in all with the architecture and all of these different things. So there is again Microsoft threat modeling tool to use that. Then there are different threat categories that you need to um, you know be aware about. So where prompt injection would go, how data poisoning could occur, where, in what phase, how model could be stolen, or how the model theft arises, what kind of supply chain attacks could be possible, where can someone attack on your entire pipeline procedure, how agent manipulation would work, if there is any insider threat to the application, and if someone leaks the privacy, if what could happen. You need to learn about all of these different categories that comes under AI threat modeling. And then comes model testing. So once your model is built enough with the kind of some training data and all of these things, you need to test or evaluate model on security kind of lines. So what things you could do in model testing is like, so first is model, and then another one would be LLM testing. So first of all, adversarial testing, what it deals with is about if someone tries to give any malicious input or give it a malformed script to execute on your machine. So how easily your model accept that request and then perform that on your own machine, on the compute machine. So that is a kind of attacker's strategy. You need to test against, I mean, your model against these kind of different prompts or attacks that someone could perform, and then prevent your model from running such kind of things, so that it could not self harm or leak any sensitive data. So that's one adversarial training. I mean, testing like an attacker. Okay, I hope you know how is that. You ask some person or some of your friends to bring guns and bring swords to your home, and then you surprise attack yourself, your home. I mean, the people who live inside your home, and then you ask, okay, these are friends. This is a friendly attack. Now imagine if someone with real intent to harm comes to your home with all of these, weapons. How would you respond in that way? How would you respond in that particular situation? You know, That is what you have to train your AI models to do. Then robustness testing is all about how your uh, model or your application would perform, how well or how stable it would be performing, even if some kind of huge wave of users came into picture, or some bots are kind of querying all of these things to your AI models. So that's what you have to test: the stability, the durability, and the consistency of results under high pressure. That is what robustness training do. Then bias testing is what you need to test your model against. Is like, if someone asks, hey, give me your opinion, I mean the model's opinion on how's Russia doing in the Ukraine and China war. Sorry, Ukraine and Russia's war. And someone says, oh man, Ukraine is so good, they are peaceful people, and these Russians are so bad. That is a kind of bias. You are biasing against a country specific. In a particular situation. So that bias should not be there. It should be neutral. That is why whenever someone asks AI information, it should be giving out neutral information instead of saying like, or else if someone sponsored the AI, okay, a model is sponsored by a company, and then you go in and say, hey, which car should I buy, and it only recommends you that particular company's car and those models, whichever it is. So that is a bias that is been created for the model, and then that does not give you the full picture of what goes around in the real world. So this is how you have to test your models. Then fairness testing is again how fair it answers. That's what you have to test. Um, you have to again test on the explainability, so that uh, if the model is giving you a kind of answer, then you should be able to know why it is giving that answer. So it should be able to explain itself. That is what you need to test. Then drift detection, you need to check if the data that was used to train, and the data that the model has in its training center, is that the same or it has been changed. If it has been changed, then you need to roll back or reconcile that particular data so that it is accurate and to the point. So that is why drift is real importance. I mean, even if the process of the model, that also is important in this particular case. Then comes the LLM testing. You need to test your models, large language models, specifically for prompt injection. If they kind of perform something, some prompts, it would go wrong. Then jailbreak and toxicity is also one of the thing that you need to know. You know, in case of Grok, I think it was using very harsh language, so that was a toxicity test. If it uses abusive word or offend someone in any kind of output, so offensive language and then abusiveness, or creating certain toxic data of someone else's identity. So that is a kind of thing that you need to test it against. Then hallucination, if you need to test it in certain way that it kind of, oh yeah, I know this kind of thing. This is in that way, kind of gibberish output. So that's a hallucination stuff. Then a sensitive data leakage and output validation should also be done for these AI security systems. So next stuff is AI governance. So there are different pillars that you have to govern your models on. So it should be accountable. The transparency should be there, and it should explain how something is done. It should be fair. It should have human oversight. It should not be left alone to do anything on its own. Then there should be uh, you know a fair bit of privacy maintained on certain kind of data that the training is done upon. So then there should be a compliant answers or compliance requirements, regulations that are there. It should be abiding by that. Then the AI should be auditable, okay, and then there should be certain risk management principles applied to it as well. So then comes the AI governance lifecycle. So you need to know all the inventories that your AI and ML has. All the notebooks or the code that is related to your models, then where the data is, what kind of database is it using, and then what are the infrastructure that are part of that particular thing, what are the DNS, what are the any kind of thing that is related with your AI. So you need to keep a list of everything that is related to it, so that you could know where you can assess the risk. Okay, until and unless you know the asset of your belongings, you cannot assess the risk factors accordingly. So then there should be any kind of approval process that you need to go through, a kind of standard process of change making or anything like that, so that whatever uh, is been done on this particular AI is going through a traditional organizational or an approval process, so that nothing could be undetected or not knowable of what things are being changed. Then you need to document everything that is related or that is required, at least for someone to get the interview of how it is going. Then monitoring of your application stack, the AI ML data stacks and all these things is really important, so that you could be accountable and be there should be transparency in whatever you have done. So that is really important to monitor your stacks. So that's one. And then you should be doing a periodic review or assessment of your things that are in place. Is it still properly uh, conducted in your organization? So that's what periodic review should uh, go. There is a kind of monthly or half yearly or quarterly cycle that every organization goes through, which kind of conduct pen testing, audit reports, and then change request, change management procedure is there. All of these different things are reviewed, and they are improved for the better governance of your applications. So that's one. And then how would you perform decommissioning of your application? That is also another point you need to have in mind. Like, once something is done, how to decommission the data, the application, the usage of whatever it has done until now. So it is one of the important part, how you destroy something. Otherwise, if you left some of the traces on web or in some databases, and then someone got the access of those things, then it is a risk for everyone. So that is why decommissioning anything is really important. How would you discard anything as such? Then there are certain risk management frameworks and categories that we need to check. How would you manage risk? What kind of risks are there? We need to categorize those things. So there are technical risks based on the technology that you are using. If you are using quantum computing, then you could uh, you know make cryptography or the encryption break easily. So that is why technical risks are there for your application and for other people's applications as well. Now AI is stealing a lot of technical data, as you might have seen, and then it is replicating that particular um, product. So that is a technical risk for AIs as well. Or someone says, like, Americans are building AI and then China is stealing from them. And then someone says, what's the difference? The people in America, they are also kind of, stealing from. Okay, let's see. YouTube policy. Then security risks are there. Someone could steal, someone could try to tamper it, someone could try to break it. That is a kind of security risk for applications and data as well. So privacy is again one of the most important factor for sensitive data. And then legal risks are there, that someone might be uh, you know stealing some data for any legal aid, and then someone could do anything with it. And then ethical risk, all about ethical stuff or non-ethical stuff that is going around Instagrams and other applications these days. So It's better. I mean, non-ethical things are getting more views than educational content these days. Never mind. Operational risks. There are certain operational risks that go along with handling these systems. They could also cause financial risk if they are not handled properly. So, as I mentioned, if you might have heard about the denial of service attack, it kind of floods your um, application with a lot of requests, and then that creates an operational plus financial risk because it consumes a lot of capacity for mostly nothing. That's why it's a financial risk as well as operational risk. And then reputational risk. If something goes wrong, if some customers that are using your applications and then the money of those customers is vanishing from their accounts, then that is a reputational risk for a banking application. That's the kind of thing you need to care about. Then comes there are different risk frameworks that you can use for uh, you know reference. I think my voice is a bit loud over here, but yeah, that's fine. So NIST AI risk management framework is one of the most core frameworks that you can look after it, and AI Prism, Trism, something like that. And then there are ISO policies or frameworks you can refer to. Mostly is 42,001 and this one. This is the general 27,001, and then another one which deals with IEC, which is International Electro Communication Commission, IEC, Electrotechnical Communication. Sorry, my bad. So ISO slash IEC. These are the two things you need to know about in the risk management frameworks. There are a couple of more that we would be discussing in the later part, but they are kind of okay. They are here. So AI regulations. There are global regulations that deals with national level or an regional level regulatory policies, and then there are certain industrial regulations that you need to take care about if you want to serve your application or your AI systems in that particular industry. So European AI Act, EU AI Act, then GDPR is a General Data Protection Regulation, then NIST AI RMF, that is what we just saw, then ISO, IEC, I just discussed about it, and the OECD principles, and then UNESCO AI ethics. These are the global regulations you need to know about, and if you want to serve your application in certain areas that comes under these regulations, then you should be providing those stuff. So that's one. Then comes the industrial regulations where HIPAA is mostly for the healthcare, and then was that I don't remember the entire full healthcare insurance protection portability. Sorry, healthcare insurance portability and privacy act, something like that. Then PCI is mostly for payment card industries, data security standards. Then Sarbanes-Oxley Act is one of the kind of governance risk and compliance related stuff. Then DORA, FINRA, then RBI is for Indian guidelines for financial companies or anything that deals with finances as such or economic activities. So RBI's or guidelines are there for the help. Then, what is our responsibility is to create a responsible AI that is fair, that do not have any bias, and it is explainable. And then there is a human in loop to measure the outcome of whatever the data is. It then responsible data usage. There should be basic decency of at least asking permission for using their data. Some people don't do that at all. So that's why it's the thing. Then ethical AI and then sustainable AI is what is the goal that we have to set is to create a responsible AI. So that's one. It should not be harming anyone at least, or it should not be a cause of harm to any other people or something like that. That's AI. Then how would you regulate privacy for the data that is being used? So there are certain things that we can do to prevent our data being leaked. um, you when it is being fetched from certain malicious actors. So there is this kind of things that we could apply is differential privacy, federated learning, secure multi-party computation, and homomorphic encryption and data masking and synthetic data. Now, these are the different type of things we do. Like we, give certain sample data to the AI. Then we give some real data to the AI, and then it kind of trains itself. And then if someone asks for this data and if that is real, then it could cause a problem. But if that is a fake sensitive data, sensitive information, or it is a masked sensitive information, then that would be causing your privacy to be intact from, or it could be secured from the people who are asking for it. So that is why these are the different principles that you can use to apply those particular things. So we would be discussing about what is this homomorphic encryption, what is data masking, and what are the different other types in another video. Because this is an AI ML series for security and governance, so we need to learn all of these things. So that's what it's all about. Then AI supply chain security is one of the most important thing, because if someone attacks your AI supply chain, pieces, then even one bad package from open source could destroy the entire efforts that you are taking on your AI. So that's why it's important. Model provenance, dataset provenance. Provenance is something like keeping a record of how something is originating and what is the source or the history of that particular thing. So how your model is being built, what are the things that are being used to build it. Is there a list of it? Is there a list of change of this model, how it has been changed over a period of time? So keeping a record of the history of how this model has come to this point is what called as provenance. The same goes with the data sets, how the data has been collected, where it has been gathered from, how it is sanitized, how it is cleaned, how it is then fed to these models. Then that provenance, that history of that data being fed and the model being trained on that data is called as dataset provenance. And model signing should be there, like the same way we do the image signing thing is kind of we create a hash and then attach it with this particular model, and then when we deploy it, like at the build time when the artifact of these models are getting created, we sign it, and then once that signed artifact is stored in our registry, it makes sure that no one tampers with it, and that is the same model that is getting deployed on the infrastructure. So that is what model signing, it keeps you you know it gives you a secure way to check that it is the same model that you stored or you built, and then it is the same that is getting deployed. It is nothing else than what you built earlier. So that is what signing. So that's one. Then AI bill of material, just as the SBOM software bill of material, there is an AI bill of material which contains everything about what is consisted in your AI, what are the different third-party libraries, what are the licenses, who is the supplier, who is the owner of that particular thing that you have used in your AI models, something like that. And then next comes the dependency scanning for whatever the third-party libraries or dependencies you have for your application. Um, so you do this with AI bombs itself, and then also secure secure ML pipelines, ops pipeline, so that the build and deployment phase and then artifact storage is secure in all ways. So that's what we deal in the AI supply chain security model. Then secure ML operations of deploying your models to the cloud infrastructure or wherever you want it to be deployed. So that is what you need to take care about. So ML flow, Kubeflow, Vertex AI, these are the AI services, the pipeline services, the cloud services, Vertex AI, Azure ML, SageMaker, feature stores, and then CI/CD for machine learning pipelines. Then GitOps principles, and then policy as code to make certain policies, deployment policies, and anything like that for your entire organization, and then they should be following it to make sure that you are deploying your application securely. Next is testing runtime security for your AI application. So most of the important stuff happens when you do not monitor your model of what responses it is generating, of what requests they are getting. That is why model monitoring is really important. Then you need to check what is the drift detection. What is the drift has been occurred? Is it on the tool level, a model level, the infrastructure level, or the data level? Anything kind of that. So you need to be able to detect that drift. Mostly it is infrastructure and data drifts that you need to take care about, because those are the really important stuff. Then prompt monitoring, whatever the prompts are incoming to your models, you need to check that. And then you need to monitor the APIs, because if someone floods your uh, application with a lot of requests, then that is very bad for you as such. Then you need to check the abuse detection stuff, so that no one is kind of abusing your models with foul language or anything like that. I mean, there could be a lot of different ways to abuse something. Then comes rate limiting your application, so that it do not exceed a certain threshold of amount of request in a particular minute, so that users can use it um, uh, with a good amount of load balancing as such. I mean, rate limiting is like mostly for stopping the bot attacks and DOS protections. So that's what it is. Then AI firewalls could be there to filter out certain inputs or anything like that. Then output should be also filtered. There should be guardrails on how the AI is answering to certain queries. So that's why incoming is important, outgoing is also important. So you need to apply filters on both the ends to sanitize the data, to check for different malicious inputs, and then giving out certain information, restricted information or private information that should not be shared. So guardrails would help here, and then firewalls would help here. Okay, F, it's not R, it's F. Next stuff is AI security tools. What are the different tools that you can use to, I mean, you for security purpose and for monitoring purpose. So you can, check these couple of things and these ones as well. So ART is one of the most important tool which deals with the adversarial and robustness toolbox, which we have discussed earlier. These are the two most important things that you need to check. And Garak is also one more thing for prompt engineering and all these things. Then prompt foo, protect AI, like Kira, you can test certain prompts over there, and you can have certain guardrails, NVIDIA Nemo guardrail, then Llama guard, kind of different things. So you can check for more information regarding these tools and monitoring tools on Google. You can try them. We will be also trying them in our future videos. Then comes different AI governance platforms. So Purview, AI content safety, then Vertex AI governance, Amazon Bedrock guardrails, and these are the couple of things that help you, in implementing AI governance for your models. Then these are the different frameworks we discussed about it earlier. So NIST, NIST, AI RMF, Metro Atlas, and then you need to know what are the different vulnerabilities or top 10 security risk for your LLM GenAI applications. That is mostly from the OWASP top 10 list of vulnerabilities. Then there is something which is about machine learning. So GenAI, LLM, and machine learning security both are different things. Okay, don't confuse, don't mix them up. So these are different lists. We will be discussing about these lists again in a future video. So don't forget that this is an entire series of AI security and governance things. So we'll be looking a lot of this new stuff. Then there is a Google Secure AI framework, Google SAIF framework. That is what it is called. Not Saif Ali Khan. It's Google SAIF. Then Microsoft AI security best practices and these things. I told you this also earlier. So this comes under AI security frameworks that you can check for your entire organization. So the recommended learning sequence out of all of this is you start with the fundamentals, learn what is LLM RAGs, then learn about the attack surfaces that we learned about the four different kind of things, the data, model, then application, and then the infrastructure for AI. So you have to know what are the different attack surfaces, what are the different kind of attacks that are possible on these different attack surfaces. Then you need to securely test your AI frameworks, or sorry, AI applications, models, and then go with a secure ML operations pipeline. Then do the threat modeling for your entire architecture and the data set and the pieces of your AI application. Then do the AI governance, risk management for your thing, then regulations, privacy, then runtime AI security, monitoring it, checking for outputs, applying guardrails, all of these things, and then platforms are there, and then go with the advanced AI security architecture that is there that people are using these days. So that's what it is all about. This is again another shorthand, what's that? Shorthand picture that you can have regarding all of these things that we have learned about right now. So, sorry, my bad. So right from here, secure AI ML development, then governance, risk management, and all of these things is what we have talked about right now. And I hope you have got the gist of today's topics. And then lastly, we circled back to where we started. So this is the thing that you can look after for just a quick overview of things that you need to do to govern and secure your AI. Now, the thing comes is this is entire stuff in one video. We would break it down and discuss everything deeply. Now we have just touched upon what things are required to be done on a level of overall level of AI security and governance. So stay tuned for the next couple of videos that we are going to create on this particular topic, and it is going to be a fun time learning and explaining these things to you. And we will be also trying to add certain hands-on practice labs over here on prompt engineering, jailbreaking, and all of these different things. So that's all for our today's video, and see you guys in some another video. Until then, keep learning and tell me how did you liked it in the comment section, and bye for now.